Welcome to Study Loop.
Okay, so we look at the diagram, it looks something like this. Now, let me actually make it a little smaller so that we can write something there. Yeah, so now we'll be applying Kirchhoff's law here. So while applying Kirchhoff's law, we'll be using two different rules. First is the junction rule, and the second is loop rule. So for junction rule, we can actually take one of the junctions that we see here. So here are two junctions. So let's actually take the left one. And if we do that, we see that I2 and I3 are going out of that point, but I1 is coming towards the junction. So that means from junction rule, we'll get I1 equals to I2 plus I3. Okay, it's from junction rule. Now we have to apply our loop rule. So let's first apply our loop rule to the outer loop, which is the bigger one where we have two batteries, and we consider our direction to be counterclockwise. So if we start from our lower left corner, we see that the direction of I3 and the direction that we chose are opposite to each other. So that means there'll be a negative sign for I3. Sorry, I think I made a mistake. Yeah, we'll be actually considering counterclockwise direction. I did a clockwise direction here. Yeah. Uh, so sorry about that. Yeah, clockwise, counterclockwise. So if we do counterclockwise direction from the lower left corner, we see I3 and the direction are same. So that means we'll have negative I3 times the resistance, which is 1.4 ohms. Then we have the battery where it goes from negative to positive. That means it's plus. Then we'll have this one where I1 and 22 ohms are in the same direction. That means it's a negative direction. So I1 times 22 ohms. Then 1.4 again. So minus I1 times 1.4 ohms. Then it goes from negative to positive again, so it's a positive 9.0 volts, and that's it. It should be zero. So, so we apply chain rule on the bigger loop, and then for the second loop, we'll also we'll consider the bottom loop, and the direction will be counterclockwise again. So like this. So again, starting from the bottom left, we'll have, yeah, starting from the bottom left, we'll have negative I3 times 1.4. Then we'll have the battery, which is 6.0 volts. Then we'll have this one. Now here, our direction and the direction of the current are opposite. So it's going to be positive 2 times 18 ohms. And that's it. So that should give us 0. Right. So now as we can see that we have three equations and we have three unknowns. So we have to find out the currents. Um, so to do so, I've already done the calculation here. So let me explain what I did here. So this is the junction rule. This is from the chain rule. This is from the second chain rule. So this is on the big loop. This one is on the bottom loop. Now, what I did here is we see that this expression, so this is from here. So in this expression, if we simplify it, we get an expression of I1 and I3. So if we substitute I1 here from this equation, we get something like this. The reason we want to do that is because we need to compare this equation with the one on the right, and since it has I2 and I3 dependency, so we want to be consistent with that. So yeah, if we substitute I1 and I3, we get substitute I1, we get an equation in terms of I2 and I3. Now, from this equation, if we solve for I2 and then substitute I2 on the big loop, we get an expression which is only dependent on I3. So we can solve for I3 and that gives us this. Now, for the direction, it's going to be right. Okay, now if we plug I3 back into this expression, we see that we get a negative sign in front of our current, which is 0.2667. So the negative sign means the direction that we chose here will be opposite to what we got. So that means this shows our direction is right, but the actual direction should be on the left. So that's why we chose this as left. Now, to figure out I1, we need to use the sign. So what we did here is I1, which is equal to 0.85. So yeah, we're writing I2 first. So we need to consider the sign here. So it's going to be 2667 ampere. Then we have to add I3 with that. It's going to be 0.8565 amps, and that should give us a current as 0.59 amps, and the direction will be on the left. So yeah, so the only trick here is, since we got a negative sign for I2, that means the given direction or the direction that we took is not correct. So that means we need to change our direction, we need to switch our direction. So instead of putting it on the right, we made it left. Thank you.